Hi kids, today is lesson 7-4, subtracting linear expressions. Short and sweet lesson again today, but please at least get to the end so we can do a few story problems because I think that's the part where we're going to get in the most trouble and it's going to be the hardest for you are the story problems. So hang with me. I really can only show you practice problems. So that's what we're going to start with. So make sure you get a few good practice problems. Today, there's tricks you have to remember, there's certain things you have to do, there's certain rules, so make sure you watch so you know those rules, all right? So yesterday, or the last video, I showed you some different ways that you can solve these. You could write them up and down, if you so wish. Okay, some of you are probably just keeping them in this format, and that is 100% okay. So you decide, same thing can go today. Now the only difference today is this is going to be a subtraction sign, so we're going to actually be subtracting things today, not technically adding them. We're going to be subtracting. Same thing goes if you're going with the up and down method, you're going to make your line in between, and remember everything is subtracting today. Okay, so for example, 4 minus 2 is still a positive 2, so plus 2. 5x minus 3x, I have 2x's. The same thing happens here. 5x minus 3x, 2x. And then 4 minus 2 is still a positive 2, so plus 2. So anyway that you want to solve today, maybe you're consistent with this way, that's fine. Maybe you're consistent with this way, that's fine. Doesn't matter to me as long as you are going to continue to do the same thing for both of these. I don't want you to get too confused. Now, the biggest thing happens today when we have negatives involved. Okay, so when we have negatives involved and we have subtraction. What is the rule called that we have to use when we have negative involved and subtraction involved? And I hope you said in your head, keep, change, change. Guys, this is going to keep showing up. Like, it's not going to go away. The thing about math is it like totally builds off each other. I don't know if you've noticed that, but it keeps building off each other. So we learned keep, change, change back in 7th grade, and it just keeps showing up. So you just got to get in the hang of it. So here's the thing about it. Technically, in this problem, there's two problems. The first problem is maybe this one. Okay. The second problem is this one. Okay, so there's really two problems going on in here, the constants and the ones with the coefficients. So I'm going to pull this down. There we go. And I'm going to show you some things. So if there's a negative involved, and negatives could be in before a number, it could technically be inside, like so even if it's a subtraction sign, it could still be a negative. We have negatives all over the place inside. And if this is subtraction, then we're going to have to use keep, change, change. Now here's the thing, if you use keep, change, change, you're most likely going to want to use it for both sets of problems, the one with the coefficient and the one with the constant. So here's how you can do this. Okay, you can keep the first set of parentheses because that's technically like the first number in both of our problems. You're going to change this to a plus. So that's like changing our middle sign. Then you're going to change every single thing in the second group of parentheses. And the reason that is because it's like the second number when you are actually doing keep, change, change in your parentheses. Even though there's two numbers in here, it's your second number when you do your coefficients. And it's the second number when you do your constant. So that's why we're going to keep the whole first parentheses, change the middle sign, and then change the end. So how this would look, this would be a plus 1, and I'll put a 1 there, and this would be a plus. So now it's an addition problem, just like what we did yesterday. So I have negative 4 plus 1, which would be negative 3x, and then my constant would be negative 6 plus positive 3, which is still a negative 3. So here's my answer for this problem. You can't just decide to change one thing and not anything else. That's the hardest thing. If you change one, you have to change everything else inside. Otherwise, it's going to be too confusing for you. Now, some of you are maybe wondering, okay, well, what if I line it up? Some of you are maybe still doing this. Okay. Okay, so here's how this would work. If you're doing it like this, you're going to keep the first line. you're going to change this, and then you're going to change everything in this bottom row. So this is going to be a plus, this is going to be a plus, and then it's the same problem that we had before. And it's an addition problem. The only thing I suggest is make sure you get a sign out here, because if you don't put a sign out here, you're not going to know what you're going to keep and change and change. So it's really important to put your subtraction sign there. Some of you get lazy and don't do that. So make sure you get everything in there you need. So if I look at this one, this is one I can use keep, change, change on because I have a subtraction in there and I have a negative in here. If I would have negatives here and here or subtraction here and here, this is another one I would have to use keep, change, change on. So this is for sure one. So I'm going to bring it down. These are so high. There we go. So I'm going to use keep, change, change. I'm going to leave it in this format. I'm going to keep this. I'm going to change this, and I'm going to change this. So I'm going to change this to a plus, I'm going to change this to a plus, and this is actually going to go to a negative. So 3x plus 2x would be 5x, and then positive 2 plus negative 1 would be a plus 1. And that is just my answer. Okay, let's try this one. Is this one I have to use keep, change, change on, yes or no? It's a yes because you have a subtraction and then you have subtraction inside here. So another thing you could think about is if it is subtraction and there's any subtraction inside those parentheses, you have to use it because eventually that's going to be a -5 and a -1. So super important to make sure you use keep, change, change on this also. All right, so here we go. So I'm going to keep, change, change. Keep this, change this. This is going to be a negative. This is going to be a positive. So now I'm going to put a 1 there also. So 1 plus -2 would be a -1x. -5 plus 1 would be a -4, so it would be a -4 would be my answer. If you want me to see it doing this way, I can quick run through it this way. I think it would look like this. Okay. So I keep this line, change this, change all this, and then it turns out to be just like what we did, and just like that. All right, I want to go through, I'm going to skip this one. I'm going to go through a story problem with you. This says the expression 5x minus 3 represents how many bags of popcorn were sold. The expression 2x minus 1 represents how many candy bars were sold. How many more bags of popcorn were sold than candy bars? So pretty simple to figure out that we're subtracting because you want to know how many more. So it would just be 5x minus 3 minus 2x minus 1. Do your subtraction. Keep, change, change is needed in this one because you have a subtraction here, subtraction here, subtraction here. So let's erase those. All right, I'm going to keep, change, change. Okay, now I can go ahead. 5 plus a -2 would be 3x, and -3 plus 1 would be a -2. Okay. And then it might say, all right, well, if x is 3, kind of like what we did yesterday, how we'll solve? So then you just put your 3 in, be 3 times 3 minus 2 be 9, minus 2, 7. So be careful with that because it might ask you to evaluate if you needed to evaluate. All right, I'm going to do one more story problem for you. So let's say you're going to buy a pair of socks, and let's say you're going to buy it from Scheels. In Scheels, you're going to buy them online, and it costs $4 for every pair of socks, but they're going to charge you $2 shipping, okay? And you're going to also buy some from Dunham's, and they're going to charge you, same socks, they're going to charge you $3 for a pair of socks, but they're going to charge you $5 shipping. So my question is, how much more expensive, or what would the, I want to know how much more expensive that Scheels is than Dunham's. So I would just take these two, and I'm going to subtract them. Oops, that should be plus 5. And we're going to subtract. And I know 2 minus 5 is going to be a -3 minus 3. 4 minus 3 is 1x. And then they might say, oh, okay, well, if you buy 10 pairs of socks, what's it going to cost you? Or what's the total difference that it's going to cost you? Well, 1 times 10 minus 3. The difference, if you buy 10 pairs of socks, is going to be $7 from Scheels to Dunham's. So that's just a way you can actually use it in real life. Believe it or not, math can be used in real life. And this is one instance that it could be. So if you have any questions, please let me know. I hope you took good notes. Thank you so much for watching till the end. I always appreciate the students who watch till the end. Let me know if you have any questions, and I'll see you tomorrow.